Okay, well, this is another lesson that we had in class. It is convection currents in the wind and how we get land and sea breezes. Let's start out with talking about convection currents. Convection currents are found in the air and in the mantle. You also find it in water, in the oceans. You have convection currents in the ocean as well. And they're caused by the flow of cooler particles sinking and warmer particles rising. So here we are, we got cool stuff up in the upper atmosphere, going to cool down and fall to the earth. The sun heats the earth up, and that transfer from the earth to the air above it, warming that air up, and then it rises back up into the atmosphere, upper atmosphere again. You have this basic situation going on where the ground warms up from the sunlight, and the air rises as it warms, gets up into the upper atmosphere, starts to cool down, and sinks back down. That's a basic, right there is a basic convection current model that shows warm particles rising, cool particles sinking, and doing this rotation. Now let's talk about our land breeze. Land breezes occur at night when the land cools down more rapidly than water. Now no, water stays pretty stable with its temperature. It doesn't get warmer and colder really fast. It takes a while for it to warm up. And so it doesn't have as much temperature change as a land mass does. Whereas a land mass, I lived in Dallas for a while, and even 10, 11 o'clock at night, that cement would still hold on to the heat and still be releasing heat up until late or even early morning hours. But by the time it got 6 a.m., it had cooled down. Okay. Now, if you lived on the coast, you would notice that the land cools off pretty quickly, but the water is still the same temperature. Well, the land will get cooler than the water, and then that cool air will move from the land to the warmer water. And then once again, we have rising air from the ocean up into the atmosphere, and with the air coming off of the land to replace that warm air and here's a diagram of that. So you have warm air rising, cool air sinking, and you can see here in this little picture where the land cools quicker than the water. Temperature of the water being about 88 degrees Fahrenheit. The land is cooled down to 78 degrees at night, and so that cool air, it travels out from the land out over the ocean and then rises up, and you have this circular pattern of air current moving from the land to the water, and we call that land breeze. I call that land breeze. So land breeze, you see it's coming from the land to the water. Let's talk about the other side. What about during the daytime when the sun is shining? When the sun is shining, we have cool air sinking over the water. You have the heated land. Now you notice that the land temperature is 89 to 90 degrees Fahrenheit during the daytime, but the water temperature is still 88 degrees. So now land is hotter than the water is. So the air above the land is going to rise up into the atmosphere, and the cooler air comes off the ocean and runs back up on the land, and then you have that breeze that comes off the water. Sea breeze occurs during the day when the land heats up more rapidly than the water. Air moves from the cooler water, because in the daytime, not that the water has changed temperatures in any way, it's just that the land is heated up. So the land is changing its temperature more than the water is. So that's what you end up having. Air moving from the cooler water towards the warmer land. That is sea breeze. That is what they call sea breeze. So you have that, or ocean breeze. You could even use that term, ocean breeze. So sun's energy, most important thing, sun energy drives all these convection currents in the wind. It's that energy, the heat coming off the sun. When the sun's not there, the land cools down. So it's the sun's energy that drives this around the world. Wind. Wind is the natural movement of air that moves from areas of high pressure and high density to areas of low pressure and low density. Note that right there. High to low density. High pressure to low pressure. It wants the equilibrium. It wants to be in equilibrium. So our atmosphere, cold out by space, not so cold down close where the sun is shining and the temperature of the land is giving off the heat that it is absorbed. Know that about 50% of the sun's energy is absorbed by the Earth's surface, and we still have this much heat going on. Well, that is basically our sea breeze, land breeze, and convection current lesson for today. Thank you all for watching. Good luck to you. See you next time.